Hello, everybody. Between last OVS Con and this OVS Con, I'm happy to report in the tree now we have a few kernel test routines. And if you haven't played with it, go ahead, look at it. It's in the tree in tests system-traffic.at, and you can run it with make check kernel. So for today's talk, we want to first report you the good news, and second of all, want to tell you about some decisions we have made along the ways of making these tests. And third of all is looking for inputs from the community to see how we can cover kernel data paths better going forward. Let's do a review on the OVS and the one secret sauce of OVS being perceived to have a very good quality is because we have lots of user space testing, and we have about 1,700 tests so far, covers most of the user space features. And it's fast to run, it's very repeatable, it's easy to write because you can copy some existing tests, and easy to troubleshoot. So we basically expect all the submission of patches to run through the tests, and if you add new features, you should also add these tests. Those are the secret to make OVS more stable for existing features. But the kernel data path testing hasn't been as good as user testing so far. One is we rely on mostly out-of-tree ways of testing it. Basically, people deploying systems will test most of the features in data path. And also, we have a very simple user space data path implementation. And we, for the most part, we assume the kernel data path and the user data path are equivalent. But in reality, it's not really true. We're still adding more complexity into the kernel data path. For example, we have a recirculation, and for most of this year, we're adding kernel contract support. So obviously, we need more coverage for kernel data path features. So we adopt the philosophy of any testing is better than no testing. We just jump in and start to write tests. So we built some test infrastructure. And there are a couple of key decisions we have to make. For example, because kernel data path is running in the kernel, it can crash. So we don't want it to crash the system you're running on. So we decided we have to run it in a virtual machine environment. So we adopted Vagrant as our environment to run the kernel data path. And secondly, how do we drive the traffic into the kernel data path? To reduce the complexity, we want to have the single VM instead of multiple VMs. So within the VM, we create a different namespace. And we use veth pairs to drive traffic through the OVS. And third one is how do we drive the test? So we decided to adopt auto test framework. So it's the same framework as we have been using for user space, and it's quite flexible. So Joe, why don't you tell us what you did with contract testing?
Sure. So with all the contract stuff, we've been using this kernel test framework to verify the behavior is correct. And so what we'll do is we'll set up a couple of namespaces. We'll place a client in one namespace and a server in another namespace, run some traffic through that, and maybe FTP. And then we'll substitute the flows that implement, for instance, a firewall or a NAT and different aspects of the implementation. And this has really given us reassurance about that code. And in terms of testing, for instance, backboard, like the CT backport, you can substitute a different VM with a different kernel and run the same tests. So, I mean, the drive of this talk is to make people aware that there's now this kernel test framework and ask for contribution and ideas from the community. The main point is that, there's a fairly small set of tests today, but we really want to expand on that. And as we expand on it, we may hit some issues. And if you've got any ideas of how to help out with this, then we'd be happy to help to talk with you about that.
All right, let's thank Andy and Joe.